Welcome to a peaceful journey through the serene landscapes of Patagonia, where ancient waters have carved their patient paths through millennia of geological time. As we settle into this gentle exploration, allow your mind to drift across the vast southern expanse that stretches between Argentina and Chile, a place where time itself seems to move with the unhurried rhythm of glacial waters. The region we will explore together rests at the southern reaches of South America, a land of extraordinary tranquility that has remained largely unchanged since the last ice age gradually released its grip some 12,000 years ago. The lakes of Patagonia exist in a state of perfect, undisturbed balance. Their waters reflect the distant mountains and endless skies in mirror-like stillness on calm days, creating a doubled reality of earth and heaven. These bodies of water, numbering over 500 across the region, form a complex network of interconnected basins and channels that wind their way through the landscape with quiet persistence. Each lake holds within its depths the story of the land, told through layers of sediment that have accumulated over countless centuries. The largest of these lakes, Lake Argentina, extends across an area of approximately 1,500 square kilometers, with a shoreline that measures 232 kilometers in its winding entirety. The surface of the lake rests at an elevation of 178 meters above sea level, while its depths reach down to a maximum of approximately 350 meters in certain locations. These measurements, while precise, can only begin to describe the immense presence of this body of water that has shaped the surrounding terrain through persistent, gentle erosion over thousands of years. As we continue our exploration of Patagonia's Lake District, we find ourselves drawn to the unique qualities of these waters. The temperature of Lake Argentina remains remarkably consistent throughout the year, varying between 4 and 7 degrees Celsius, a coolness that speaks to the glacial origins of much of its volume. This consistency creates a stable environment for the diverse ecosystem that has developed in and around these lakes, a system that has adapted to the rhythmic patterns of Patagonian seasons over countless generations. The color of these lakes varies from deep azure to milky turquoise, depending on the mineral content and the presence of glacial sediment suspended in the water. This suspended rock flower, as it is sometimes called, is the result of the grinding action of ancient glaciers against the underlying bedrock, producing particles so fine they remain suspended in the water column for extended periods. The varying concentration of these particles creates the distinctive coloration that characterizes each lake, from the deep blue of Lake Nahuelhuapi to the milky teal of Lake Argentino near the Perito Moreno Glacier. The topography surrounding the Patagonian lakes was primarily shaped during the last period of significant glaciation, which reached its peak approximately 22,000 years ago. During this time, massive ice sheets extended across the landscape, carving wide valleys and deep basins through the persistent action of ice against rock. As these glaciers gradually retreated, they left behind a terrain characterized by U-shaped valleys, hanging valleys, and deep, rounded depressions that would eventually fill with meltwater to form the lakes we observe today. The eastern shores of many Patagonian lakes are characterized by gentle slopes that rise gradually toward the distant plains. These slopes are typically covered with native grasses and small shrubs adapted to the persistent winds that sweep across the open landscape. The gradient of these eastern shores typically ranges between 2 and 8 degrees, creating accessible approaches to the water that have historically facilitated human interaction with these bodies of water. The soil composition along these shores consists primarily of glacial till, a mixture of clay, sand, and gravel deposited directly by the retreating ice sheets. In contrast, the western shores of many lakes rise more dramatically toward the Andean peaks, with gradients often exceeding 25 degrees and occasionally approaching vertical in areas where ancient glaciers carved particularly deep channels. These western shorelines frequently consist of exposed bedrock, primarily granite and metamorphic formations that date back approximately 150 million years to the Jurassic period. The resistance of these rock formations to erosion has preserved the dramatic topography created during periods of glaciation, resulting in the striking visual contrast between east and west that characterizes many Patagonian lakes. The watershed of the Patagonian Lake District encompasses approximately 130,000 square kilometers, an area that includes numerous smaller river systems and tributary networks. The drainage patterns within this watershed have developed over thousands of years, with water generally flowing from west to east, from the higher elevations of the Andes toward the Atlantic Ocean. This pattern is occasionally interrupted by geological features that redirect flow, creating the complex network of interconnected water bodies that defines the region. The lake basins themselves vary considerably in their morphology, with some featuring relatively simple bowl-like structures, while others display more complex formations with multiple subbasins separated by underwater ridges or moraines. Lake Viedma, for instance, has a central basin with a maximum depth of 440 meters, while its eastern extension reaches depths of only 70 to 90 meters due to the presence of a submerged moraine that partially divides the lake. These underwater features influence water circulation patterns, temperature distribution, and biological productivity throughout the lake system. The shorelines of Patagonian lakes extend for a combined total of approximately 3,400 kilometers, creating an extensive interface between aquatic and terrestrial ecosystems. These shorelines vary in their composition and structure, from sandy beaches and gravel shores to rocky outcrops and steep cliffs. The variation in shoreline characteristics creates diverse microhabitats that support a range of specialized plant and animal communities adapted to these transition zones between land and water. The Patagonian Lake District contains approximately 523 named lakes, with surface areas greater than 1 square kilometer. Of these, 42 exceed 100 square kilometers in area, and 8 exceed 500 square kilometers. Collectively, these lakes hold an estimated volume of 2,300 cubic kilometers of freshwater, representing approximately 0.06% of the world's liquid surface freshwater. This substantial reservoir plays a critical role in the regional hydrological cycle, influencing local climate patterns and supporting diverse ecosystems. The average depth of the major Patagonian lakes is approximately 170 meters, though this figure varies considerably between individual water bodies. Lake San Martin, for instance, has an average depth of 313 meters, while Lake Fagnano averages 122 meters in depth. These variations reflect differences in the underlying geological structures and the extent of glacial excavation that occurred in each basin during periods of extensive ice cover. The water residence time, the average period that a water molecule remains within the lake before flowing out, varies from approximately 7 years for smaller, more rapidly flushed lakes to over 100 years for the largest and deepest basins. Lake Argentina, with its substantial volume and relatively limited outflow, has a water residence time of approximately 83 years. This extended residence period allows for the development of distinct physical and chemical characteristics within the lake, creating a unique aquatic environment that differs from the surrounding river systems. The combined surface area of all Patagonian lakes exceeds 27,000 square kilometers, representing approximately 4.2% of the total land area of Patagonia. This ratio of water to land is significantly higher than the global average of approximately 0.6%, reflecting the distinctive hydrological character of the region. The spatial distribution of these lakes is not uniform across the landscape, with a higher density occurring in the zone between 41 and 51 degrees south latitude, where the effects of historical glaciation were most pronounced. The water balance of the Patagonian lake system is maintained through a combination of inputs and outputs that operate across seasonal and annual timescales. Approximately 62% of the water entering the lakes comes from direct rainfall and snowmelt, while the remaining 38% is supplied by glacial meltwater and groundwater discharge. Water leaves the system primarily through river outflow, 78%, and evaporation, 22%. With the relative importance of these processes varying seasonally according to temperature and precipitation patterns, The chemical composition of Patagonian lake waters reflects the geological character of the surrounding landscape. Most lakes are classified as oligotrophic, meaning they contain relatively low concentrations of nutrients and dissolved minerals. The average total dissolved solids concentration is approximately 65 milligrams per liter, with calcium, sodium, and bicarbonate ions being the predominant chemical constituents. This chemical profile creates water with exceptional clarity, with Secchi disk visibility often exceeding 20 meters in the clearer lakes. The climate surrounding the Patagonian lakes is classified primarily as a cool, temperate climate with strong maritime influence, particularly in the western regions closer to the Pacific Ocean. Annual precipitation varies considerably across the region, decreasing rapidly from west to east due to the rain-shadow effect created by the Andean mountains. The western lake shores typically receive between 2,000 and 4,000 millimeters of precipitation annually, while eastern shores may receive as little as 300 to 700 millimeters. This precipitation gradient creates distinct ecological zones around the lakes, with temperate rainforests dominating the western shores and steppe vegetation characterizing the eastern regions. The transition between these ecological communities occurs gradually across the lakes, creating a unique environmental gradient that can be observed in the changing vegetation patterns along north-south oriented lakes that span the precipitation gradient. The seasonal distribution of precipitation around Patagonian lakes follows a relatively consistent pattern, with maximum rainfall occurring during the austral winter months of June, July, and August. During this period, approximately 48% of the annual precipitation occurs, driven by the northward shift of the polar front that brings consistent westerly storms to the region. Spring and autumn each receive approximately 22% of annual precipitation, while summer months contribute only about 8% to the annual total. Temperature patterns around Patagonian lakes display moderate seasonal variation, with mean annual temperature ranging from 6 degrees Celsius in the southernmost lakes to 11 degrees Celsius in the northern part of the region. The annual temperature range, the difference between the warmest and coldest monthly averages, is typically between 9 and 12 degrees Celsius, reflecting the maritime influence that moderates temperature extremes throughout the year. January and February are typically the warmest months, with average temperatures ranging from 12 to 16 degrees Celsius, depending on latitude and proximity to large water bodies. During these summer months, daytime temperatures may occasionally reach 22 to 24 degrees Celsius during clear, calm conditions, though such warm periods are generally short-lived due to the persistent influence of cool maritime air masses. July and August represent the coldest period of the year, with average temperatures ranging from 1 degree Celsius in the south to 4 degrees Celsius in the northern parts of the region. During particularly cold winter periods, temperatures may fall to -10 degrees Celsius, especially in areas further from the moderating influence of the lakes. These cold periods typically last between 3 and 7 days before being displaced by warmer maritime air masses. The seasonal temperature cycle influences the physical properties of the lakes themselves, though the effects are less pronounced than in lakes at more northerly latitudes. Surface water temperatures in the larger Patagonian lakes typically range from 4 degrees Celsius in winter to 12 degrees Celsius in late summer, with smaller and shallower lakes experiencing somewhat greater temperature variations. This relatively narrow annual temperature range helps maintain consistent conditions for aquatic organisms throughout the year. Wind patterns around Patagonian lakes are dominated by the persistent westerlies that characterize this latitude band, often referred to as the Roaring Forties and Furious Fifties, in reference to their position between 40 and 50 degrees south latitude. Average wind speeds typically range between 15 and 25 kilometers per hour, with stronger winds of 40 to 60 kilometers per hour occurring regularly during storm passages. These winds create distinctive wave patterns on the lakes, with wave heights commonly reaching 0.5 to 1 meter during average conditions, and occasionally exceeding 2 meters during severe storms. Human interaction with Patagonian lakes extends back approximately 12,000 years, when the first indigenous groups began to inhabit the region following the retreat of the ice sheets. Archaeological evidence suggests that these early inhabitants primarily utilized the lakes for fishing and transportation, with seasonal movements between summer and winter territories often following lake shorelines and connecting river systems. The remains of ancient settlements are most commonly found on eastern and northern lakeshores, where more moderate terrain and climate conditions facilitated longer-term habitation. The indigenous Tehuelche people developed specialized techniques for navigating and fishing the Patagonian lakes, constructing canoes from hollowed tree trunks and developing fishing implements suited to the specific conditions of these deep, cold waters. Their relationship with the lakes was characterized by sustainable utilization of resources and a profound spiritual connection to these bodies of water, which featured prominently in their mythology and cultural practices. European exploration of the Patagonian lakes began in earnest during the late 19th century, with scientific expeditions led by Francisco Morno, Hans Steffen, and other explorers who sought to document the geography and natural history of this remote region. These early scientific voyages produced the first detailed maps of many lakes and established the foundation for subsequent geological and hydrological research that continues to the present day. Permanent European settlement around the Patagonian lakes developed gradually during the early 20th century, with small communities establishing themselves at strategic locations along the shorelines. These settlements typically focused on sheep ranching, forestry, and small-scale agriculture, with the lakes serving as important transportation corridors in a region where overland travel remained challenging due to the rugged terrain and limited infrastructure. The current population density around Patagonian lakes remains relatively low, averaging approximately 1.7 inhabitants per square kilometer across the region. The largest lakeside settlements include Barrelage, with a population of approximately 135,000 residents, and El Caliphate, with approximately 22,000 permanent inhabitants. These communities rely primarily on tourism, agriculture, and natural resource industries for their economic sustainability. Tourism has emerged as a significant economic activity around Patagonian lakes in recent decades, with approximately 940,000 visitors traveling to the region annually. The majority of these visitors, 67%, come during the austral summer months of December through February, creating a distinct seasonal pattern in human activity around the lakes. This tourism is primarily focused on appreciation of natural landscapes, with activities such as hiking, fishing, photography, and wildlife observation being the predominant forms of visitor engagement. Conservation efforts in the Patagonian Lake District have resulted in the establishment of numerous protected areas, including 7 national parks and 12 provincial reserves that collectively encompass approximately 38% of the total lake surface area. These protected areas impose varying levels of restriction on human activities, creating a management framework intended to balance ecological preservation with sustainable human use of lake resources. Scientific research on Patagonian lakes continues to develop our understanding of these unique ecosystems and their response to changing environmental conditions. Current research focuses primarily on limnological monitoring, paleoclimate reconstruction using lake sediments, and assessment of potential impacts from global climate change. Long-term monitoring programs have been established on 17 major lakes, providing continuous data on physical, chemical, and biological parameters that inform both scientific understanding and management decisions. As our journey through the ancient lakes of Patagonia draws to close, we can reflect on the profound tranquility that characterizes these remarkable water bodies. Their enduring presence on the landscape represents a connection to geological processes that have shaped our planet over immense spans of time, a reminder of the patient, persistent forces that continue to mold the Earth's surface with quiet determination. In the gentle lapping of waves against the shore, in the subtle play of light across still waters, in the slow seasonal rhythms that have repeated without interruption for thousands of years, we find a natural pace that invites us to release our daily concerns and embrace a deeper, more restful awareness of our place within the continuing flow of time.